right, so we're looking at chapter 2, chapter 10, section 2. We're going to look at the examples today out of your book. So you should have your book open at chapter 10, section 2, example 1. Our standards are the same as yesterday. We're going to be multiplying powers with the same base. Find a power, product of a power. So to start, I'm going to have you guys write down these key ideas. They are out of your book, but I am asking that you guys write them down on a separate sheet of paper. What do you think these things would be good for?
Wait, do we write the thing that says like next to numbers?
You're going to write all of this down in your notes.
We can put it on a note card.
Thank you, Jordan. Yes, this would be an excellent thing to put on your note card for when you take your next quiz, which is already on the board, as you can see. So I'm going to give you guys some time to write this down. We're going to pause at this point. Okay, so all three of these product properties are very important to this chapter. They're actually really simple when you break them down and understand them. And these would be really good pieces of information to put on what, Jordan?
A note card?
On a note card, absolutely. Okay, so the product of powers property, these are tongue twisters for me. All it tells you is when you're multiplying numbers that have exponents, as long as their base is the same, you're going to add the exponent. Same base to a power, you're going to add the exponent. The next one, the power of a property, power of a power property. What do parentheses mean? Like, let's say we have 2 in parentheses and then a 3 outside of the parentheses. What does that tell us to do? Skylar?
Multiply.
We're going to multiply. So because these have those parentheses, we need to really look at this as a multiplication issue. So this is going to be 4 to the 6 times 3. So we're actually going to be multiplying our exponents. Okay? Now remember those parentheses meaning multiplication is a big clue that tells you that this is going to be different than this. Okay? And the last one, the power of a product property. So it says to find a power of a product, you have to find the power of each factor. Okay, so inside the parentheses, I have 2 factors. I have a 3 and a 2. I'm not going to say 3 times 2 to the 6th power. I actually have to apply this power to every factor inside that parentheses. Okay, so it ends up being 3 to the 5th times 2 to the 5th. Okay, this one will probably give you the biggest trouble, but it's really not that difficult when you really understand that anything inside this parentheses, you have to apply this power. Why not here? How many factors do I have in here? 1. Okay, and it would be the same as saying this is 3 to the 1, right? So 5 times 1 is
5.
So this is 3 to the 5. Okay, it's technically very similar to this, but it's a little different because we have multiple factors inside your parentheses. Yes?
So we don't have to do 3 times 3 times 3 times 2.
You do have to do 3 to the 5th.
Okay.
And you will have to do 2 to the 5th. And then you multiply them by each other. Okay? All right, so example 1 in your book is just an example of your product of powers property. So this, do they have the same base? We have 2 to the 4th times 2 to the 5th. What is the base?
The base is 2.
2. And what is the exponent for this one?
4.
And the exponent for this one?
5.
Good. So we're going to add our exponents. There's no parentheses, there's no multiplication. There is multiplication, but there's no parentheses. So we're going to say same base of 2 to the 4 plus 5. Understand?
Yes.
Here I do have parentheses, but so I'm going to use that same rule and I'm going to apply this to this, right? So negative 5 to the 6, and that's what I have here. But I just have a negative 5 here. Does this negative 5 have a power?
No.
Absolutely it does. It is to the power of 1. Okay? So because I have the same base, are these both the base of negative 5? I'm going to add my exponents. And it's really important that you remember that this power, when you have a factor all by itself without an actual exponent, it is to the first power. Because a lot of times you'll forget and you'll say, oh, well, it's negative 5 to the 6. No, it's negative 5 to the 1 plus 6. So it ends up being negative 5 to the 7. Right? So yesterday I kind of talked about negative integers when we're doing negative integers to powers, right? This has an exponent of 7. So my answer, what's it going to be? Positive or negative?
Positive. Negative.
I heard both. Who says positive? Raise your hand. Who says negative? Why do you say negative, Ruben?
Because from the starting, I think because of since it's negative, it's gonna be negative.
Because it begins negative, it's negative? Well, you have the right answer. You have the right answer to my answer is going to be negative, but your reasoning is flawed. Okay? So my answer is going to be negative. Micah, you want to give it a shot?
Because the power is odd.
Because my exponent is odd. So remember, anytime you have an odd exponent, right? Because you have negative times negative is going to give you positive, right?
Yeah.
So 2, or an even exponent, is going to give you a positive answer. But when you have negative times negative times negative, that's an odd number, right? 3. Negative times negative, positive. Positive times negative, your answer is always going to be negative. Right? So that's kind of reviewing something that I might not have hit strong enough yesterday. So I want to make sure that you understand when you have a negative number that you're multiplying times itself, if that exponent is odd, you're going to have a negative answer. If this was negative 5 to the 6th, would my answer be negative or positive? Positive, because it's an even number. Okay? Here we have variables. Same rules apply to a variable that they would to a whole number and any kind of an integer. Okay? So I have x to the 3rd times x to the 7th. What's my base? X, right? X is my base. Are there parentheses telling me that I'm doing power to power, or is it just products of a power?
Just product of the power.
Right, so I need to do what to my exponents? Add them. So this becomes x to the 3 plus 7, which is x to the 10. Okay?
Yes.
Pretty simple, right?
Yes.
Pretty basic exponential information. So let's go ahead and look at example 2 in your book. And you know, it really wouldn't be a bad idea at all if you had probably put down an example of these examples. But they are in your book, so when you go to do your homework, you know where to refer back to, right? Okay, so power of a power. Here's when we have a factor to a power inside of a parentheses raised to an additional power. Okay, so power of a power tells me I'm going to do what? Multiply. So I take my exponents. Here's my base, 3 to the 4 times 3, which is going to give me 3 to the 12. Okay, again, simple concept. The problem is remembering which concept you're going to apply when. Right? Same thing applies to a variable. Here I have w to the 5th and parentheses again to the 4th power, so it's power of a power.
So you have to add those powers.
I'm not adding because I have parentheses.
Multiply.
I need to multiply, right? So this becomes w to the 5 times 4, which is w to the 20th. And notice it says simplify, it doesn't say solve. Do you guys notice that? So do I have to do 3 times 3 times 3, 12 times over here to get this? No, I just need to simplified answer, okay? And your homework, I think, mostly says simplify. Example number 3. Product of a power. Okay, so this time I have more than one factor inside my parentheses, right? So, and I have these two factors inside of parentheses raised to the 3rd power. Okay, So I'm going to say that this 3 is going to apply to every factor inside those parentheses. Right? So Ryan, you're looking a little tired over there. So what does that tell me? Since I have 2 and x inside my parentheses, this 3 is going to go how? 2 to the third times x to the third. Because this really says 2 times x, right? So simplifying that, oops, sorry about that. 2 to the third power, or 2 cubed, is 8. And then I add my x to the third, 3 tags along. Right?
So if it was x first, then it would be x. X to the, or just x and then 8 to the power.
Yes, except that when we write our numbers and variables in algebraic form, you always start with your numbers first, and then your variables in alphabetical order. Okay? So, alpha. That says alba. Alphabetical order. So let's say, for example, that's a really good question. Let's say that we had 2 and 3 x. No, let's not do x. Let's do 3b. Good. To the third power. How would I write that out?
2 and
Well, first I'd have to apply my exponent to every factor in here, right? So it would be 2 to the third. Then I'm going to pull this out first. Times 3 to the third. Which one should I pull out first, N or B?
and
Which
Oh,
one?
B.
B. Alphabetical order. So B to the third, right?
and then
Times N to the third. And then my ending product, which 2 to the third is what? 2 times 2 is 4, times 2 is 8. So I have 8, and 3 to the third is, 3 times 3 is 9, times 3 is 27.
yes.
And then I'd have b to the third, n to the third. And I still have to multiply these guys out to get my final answer. Right?
Yeah.
That makes sense? So numbers first, and then variables in alphabetical order. Okay. I don't remember. Did we finish B?
No.
I got sidetracked. Okay. So here, again, 3 different factors, but 1 exponent. So this exponent is going to apply to everything. It's going to apply to the 3, it's going to apply to the x, and it's going to apply to the y. So I have 3 squared times x squared plus y squared. I can solve this to simplify. 3 squared is 9, x squared y. Okay, so take the next 5 minutes. And if you have questions in your table groups, make sure you guys ask each other some questions to solve these problems. I want you to go ahead and do 1 through 9 on your own section right now. Ready? Go ahead. 5 minutes. I'm starting the timer now. All right. So hopefully you guys were able to take care of all 9 of these in that time that I gave you. So let's go over them. And they're actually pretty simple. So I'm going to ask for some volunteers. So Micah, since you're so animated back there, why don't you go ahead and help me out with this first one here, number 1. I have 6 to the second times 6 to the fourth. How would I simplify that expression?
You want me to give you the answer?
Yeah, how would I what would I do?
Multiply 6. Or no, first you add the exponents.
Okay, so I would have 6
Yes, you would.
to the 2 plus 4,
Yes.
and that would be what?
6.
What about
6
the
to the 6. Yeah. And because it says simplify and it doesn't say solve, I'm really not expecting you to go 6 times 6 times 6 and tell me what 6 to the 6th is.
36.
Okay, it's not. 6 times 6 is 36, but 6 to the 6th.
Whatever. Okay,
Right.
Sorry.
All right, so number 2, who's going to be a willing victim? I mean volunteer. Skylar, go ahead.
Oh, okay. What you're gonna wanna do is just add the exponents together.
Again, so I'm still adding exponents, right? 1 to the 3 plus 6. So what does my answer end up being?
It's gonna be
Perfect. Okay. Number 3, race.
Um,
Victor. Kevin.
V to the 12th power?
Victor and Kevin. Okay, so what am I doing here, race, on number 3?
Honestly, I don't know. Wouldn't you put the Z's together?
I put the Z's together. So what's the power of this Z here?
Nothing.
Ryan, you want to help him out?
Oh,
One.
One.
1, right?
Yeah.
So now this one looks an awful lot like that one. So what do I do to my exponents, race?
Add them.
I'm going to add my exponents. So this becomes Z to the what?
Second or first.
1
1,
plus.
4, or 12.
So my final simplified answer would be Z to the what?
13th power.
Yes.
Right.
Yeah, dude.
Got it?
Yes.
Okay. All right, number 4. Ava, why don't you help me out with number 4 here? So I have parentheses here. Okay, so what am I going to do to my exponents? So what's my base? And then I'm going to multiply what two exponents? 4 times 3. So my answer is going to be what? 4 to the 12th. Got it?
Yeah.
Right? Easy peasy lemon squeezy. Let's try number 5. Ruben, you look like you're dying to help me out here. Very similar to number 4, right?
You multiply 2 times.
Well, what's my base?
Y.
Y.
Now you multiply 2 times 4, which equals 8.
So my answer is y to the 8th.
Yeah.
Excellent. Very good. All right, let's try number 6. Jordan.
Oh, okay, so
I didn't know you were recording.
I just find 3 times 2, and I got -4 to the power of 6.
So you multiplied your exponents, right? So you did
Yeah.
-4 to the 3 times 2. Oh, that's a times.
Yeah.
And you ended up with -4 to the what?
To the 6.
To the 6th power. Is he right?
Yeah.
Yes, he's right.
Yes, I got it.
Okay, number 7. Steven, why don't you work on number 7 with me?
Okay. Okay, for there's a 5 of a y and there's a 4
Right?
on there. That means multiply. So 5y and equals 5y 4, right?
Did we forget something?
Yes.
What did we forget?
It's not funny.
What did we forget? Steven.
Um,
Remember, how many factors do I have inside here?
1,
No.
4.
I have
Five.
5 and y. Okay, so this 4 has to attach to both of them, right? So 5 needs this. So it's going to be 5 to the what?
5 to the power of 4.
Mm-hmm. And then
Y 4.
to the power of 4. Okay? So I can still simplify this, right? I can say 5 to the 4th, which is going to be 625. But I'm okay with you guys just giving me the exponential notation at this point. Because 5 times 5 times 5 times 5 is 625.
How'd
Mm-hmm.
you know that?
Because I did this morning.
Oh.
Yeah.
Wait, where's your...
So number 8. Who wants to do number 8? Kevin, do number 8 with me.
Yeah, Kevin.
This is 1, right? And this is 1. I don't add them. Why don't I add them, Kevin? What do these parentheses mean? Multiply, right? So how do I multiply this out? What's my first factor that I'm going to bring out here? What factor am I going to bring out here? A. I'll bring out my factor of A. So I'm going to multiply 1 times 5, right? Which gives me what, Kevin? 1 times 5 is 5. What's my next factor that I'm going to bring out, Kevin? Huh? B. And what exponent am I going to add to this here? 5. Okay, that makes sense?
Yes.
Yes.
Accepted.
This exponent is going to attach to both factors in here. Okay? It's going to get a little bit trickier, but this is the basis and your foundational stuff, and this is actually probably the easiest. So, Victor,
Yes.
number 9.
0.5 n to the power of 2.
So you're saying 0.5 what?
Oh no, I was just reading now.
Oh, okay. Sorry.
But you are gonna put 0.5 n,
Uh,
and then right beside it you're gonna put 0.5 n.
like this?
Oh, I said m and then n.
There's an M.
Like this?
Put
Stop it.
then on the
Stop
0.5
and tell.
n, put it to the power of 2, and then to 0.5.
Let me ask you a question before we continue with this.
To the power of 2.
How many factors do I have inside this parentheses?
2.
2?
Wait, 1.
1?
1.
I have 0.5,
Yes.
and then what else do I have?
The mn.
I have m,
N.
and then n. So how many factors do I have inside this parentheses?
3.
3. So how many factors should have a power to the second power?
3.
So how can I write this with each of these factors having a second power?
0.5, 0.5 n, and then 0.5 n. To the power of 2.
N to the power of 2? Just n?
No, all of them.
All of them should have. So I should have 0.5 to the power of 2,
Yeah.
and then
That's the power of 2.
m2 and n2. Okay? Got it?
Yeah.
Okay, you totally went the long way around it, but I need you guys to make that connection that everything inside these parentheses, you need to kind of separate them out and give them each that power. All right? I could probably simplify this to 0.25 m squared n squared, because that's what 0.5 squared is. But I'm not going to ask you to. I'm just going to ask you guys to simplify it. Any questions on what we've done so far?
Oh man.
All right, take out a second sheet of paper, put your heading on your paper, and start your homework.